Today we're working on the Forerunner, and specifically we're going to be talking about pinion angles, and this applies to pretty much any four-wheel drive vehicle or any lifted vehicle, and we're talking about the driveline today and how pinion angles and double card and U-joints and single U-joints and all that stuff, how they all work together and how they matter. So recently this truck got a new leaf pack, so the rear end was lifted, and it also got this high clearance cross member here, and that lifted the drivetrain up a little bit. So now we have changed the angle between the drive shaft and the transmission and the drive shaft and the pinion on the differential. So why does any of this even matter? I mean, it's got U-joints. U-joints allow everything to bend and still spin. It shouldn't cause any sort of problem, right? Well, it can. There's a little bit more to it. So let's get some theory down. First, let's talk about a very simple drivetrain system. So let's imagine that this shaft here, that represents the engine. The output shaft of the transmission, this is that axis. This is where it is, okay? This line here will be the drive shaft. My marker's dying. Okay? And then this shaft here will be the pinion on the rear differential. And then an X will represent a universal joint. Okay? So at this point the universal joint is not actually bending at all. It's perfectly straight, right? But this has to be here because, you know, your suspension moves up and it moves down a little bit, and if it was a solid bar, well, it would be bending and that would just cause it to wear out or break. So we need these universal joints here because the suspension moves. Now let's go to another case. Let's say there's your engine and here is your pinion. Now these two lines are parallel, you see, but they're not coincident. They're not the same line, which means that your drive shaft is going to be like this, and now you're going to have a universal joint here and a universal joint here. Now, a universal joint needs to be, well, a universal joint doesn't actually spin at a constant velocity. That's why they're not called CV joints. When the input of a universal joint spins, the output spins faster and slower, faster and slower. So the overall speed is exactly the same, but it's a wave. It's not a line. So that means that you need another one to cancel that out. So that's why the two angles here need to be exactly the same, because whatever this one does, this one will undo as long as the drive shaft is in phase. Okay, so now we've removed the drive shaft from the vehicle, and now you can see what I'm talking about with the phase. So you notice that the inside yoke on this end is pointing straight vertical up and down, and the inside yoke on this end is doing the same thing. Since these two are in line, the vibrations caused by the misalignment of the first universal joint, the first single universal joint, is canceled out by this one, the second U-joint. Now if they were 90 degrees out of phase, this one would not cancel it out. It would be exactly double whatever that one's doing, which means that your vibrations would be twice as bad. So you got to make sure that when you if you disconnect the slip yoke here, that you're phasing them correctly, and, you know, make sure that if one's vertical, the other is vertical as well. It's very important. So this would actually work fine. There would be no vibrations, and as your suspension moves up or down, you know, it would be fine. So now let's see another case. Let's say you have this is your transmission output, and this is your pinion angle. So now if we put the drive shaft here and we put a single universal joint here and a single universal joint here, this won't work. This is bad. These are good. This is bad. This right here won't cancel this out because this is basically at a 0 degree angle. You see, this one, we'll call this, like, you know, whatever this goes here. This angle is probably like 5 degrees, and this one as well. This angle in here, that's probably also 5 degrees. So they cancel each other out. These are both 0 degrees, so there's no vibration. Whatever vibration is caused by the 5 degrees is canceled out here. But if this one was 5 degrees, right in here, and this one is 0, then we're going to have a vibration. Okay? So what do we do to fix that? Because it is possible to have your pinion not parallel with your output of your transmission and have no vibrations. Well, that is what a double card in is for. So let's say there's your drive shaft, here's your pinion. Now you have a single universal joint here, and over here you have a double cardan. So a double cardan is basically both of these pushed real close to each other. So right here, whatever vibration there is in the center of the double cardan is canceled out by the output of the double cardan. And then right here we still need a universal joint here, because this is going to change by a fraction of a degree as the suspension cycles up and down. So you need to have something here, but you want this one to be as close to zero as possible, and the double cardan will act as both ends of this. So that's what the double cardan is for. So what we're actually dealing with today on my truck is a problem sort of like this, where this angle here does not match this angle here. This angle here might be like 3 degrees or something, and this one's 5 or 6. I don't know what they are. But we're going to figure that out, and then we're going to show you how to fix that. I'm also going to write a little check mark here. So how do we actually figure out the angle between the transmission and drive shaft and the drive shaft and the pinion? Well, that, my friends, is where this comes in. You can pick these up at Lowe's or Home Depot or something like that, and they cost less than 10 bucks. And you know how most tools, you'll probably find, you might not have one, but I'm sure that if you buy one of these, you'll find uses for it. Because, I never needed a welder, but then when I was 16, I bought a welder, and suddenly everything needed to be welded. So, go ahead and buy it. It's a good investment. Plus, you need it for this job. Alright, now I need to remove this drive shaft as well. So, on Toyotas, it's pretty easy, but whatever vehicle you're working on, you'll have to remove the drive shaft. Okay, so we've got the angle finder here. We got it. It's magnetic, so it's sticking there to the pinion flange. On some other vehicles, you might not have this nice flat surface here. Toyota did that, and it just happened to work out for us. But I know that some Chrysler vehicles, you got the U-joint. The yoke is right here. So you might have to do some rigging, put some flat plate or something there. But you want to get you want to be able to figure out what angle this plate is at. Now, 90 degrees apart from whatever this angle is the angle of the pinion. But it's not. We don't need to add or subtract anything. Well, all we really need to know is the angle that's between this and that, and you want it to be zero. You want them to be parallel. The absolute angle doesn't matter. You just want the relative angle between them, and you want that angle to be zero. Something else I should note is that you want the vehicle to be loaded just like it normally would. So you don't want to do this on a 2-post lift, because then the suspension will be all decompressed. We actually got it on a 4-post lift here, a drive-on lift. And another thing you want to make sure of is that you can do this on the ground too. You also want to make sure that there's no torsional load on the axle. So you don't want the parking brake to be on a big hill. You want to try to do this on sort of level ground, because that will make a little bit of difference. And we're trying to get a pretty precise angle here. So you don't want to have the parking brake on a big hill or in gear on a big hill, because that'll twist the axle backwards a little bit. We're looking at the pinion here, and you can see we're sitting right at around 82 degrees. And we're going to do the same thing on the transmission output, and then see what the difference is between them. Okay, so you can see the setup there on the transmission output. That one actually measures 86 degrees. So 86 minus 82 gives us 4 degrees of misalignment. And that's actually enough to cause vibration that you would notice at highway speeds. So now let's see what we got to do to fix that. So what is it that we can do to actually change the angle of the pinion or the engine? Well, you can change the angle of the engine, but that's pretty difficult. You'd have to either raise or lower the rear end of the transmission, or raise or lower the front of the engine. That's not terribly easy. In some applications that might be necessary, but in leaf-sprung applications it's actually not nearly that difficult. So with leaf-sprung applications, you can change your shackle length, and there's some geometry that goes into that, but you can add some inches to your shackles, and that'll tip the pinion up a little bit more. You can also shorten the shackles, probably not in my case, but if you do that, it brings the pinion down a little bit more, and that's what I need to do. I need to bring the pinion down a few degrees. So shackles, they're pretty easy, plus you get a little bit of lift out of them, which may or may not be what you're looking for. Another thing that you can do is you can buy shims that go in your leaf packs, and they go right between the leaf pack and the spring pad there that's welded to the axle. And so all you have to do is unbolt the U-bolts, stick your shim in there, bolt everything back up. So that's what I'm going to do. Okay, so we've determined that we need a 4-degree axle shim. But where do you go to get an axle shim? Well, if you're lucky, you might have a 4x4, some sort of, or maybe a driveline shop that stocks that kind of stuff or can get it for you. But I'm going to order them from online, and I'm going to show you where I get them. go to fourcrawler.com, and then just come down here and click on Four Crawler Off-Road. And if you scroll a little ways, you can see right here, custom axle shims. Now this guy specializes in Toyota stuff, so that's why I'm ordering from him, but he'll make them for anything. I mean, you give him the width, the length, center pin diameter, thickness, center pin placement. I mean, he'll make them he'll make anything you want. They're all in drop-down menus, so it's actually pretty easy to navigate. Alright, so we got the leaf pack all pulled apart here, and we got our shims in the mail. I ordered these on Tuesday. Today is Friday, and yeah, they're already here, so that's real fast, thanks to Four Crawler. So we're going to put these shims in. We're going to make sure they're oriented the correct way, and then we'll start bolting the leaf pack all back together. Alrighty guys, so just finished up the spring shim install, and now we're taking it out on the highway to demonstrate that there are no driveline vibrations at any speed. So we're at about 35 now, merging onto the road, and coming up a big hill, so we're going to put this 22RE to the wood and try to get up to some speed. There's 50, nice and smooth. Works pretty good. I'm actually pretty happy with it. It came out just growling perfect, so let's get it up to 70 just to demonstrate that everything's working well. Obviously there we got some wind noise, but as far as vibrations go, it's a nice and smooth ride. We're 65. Still running nice and smooth, so the shim install went good, and definitely cures the problem. So you can just follow this tutorial, you should have no issues whatsoever. Thanks for watching. As always, see you next time.
That's what you wanted. Where'd it go? There it is.